The 5 Hazards of Human Spaceflight. This is an article by the National Air and Space Agency, NASA, about the 5 hazards. A human journey to Mars at first glance offers an inexhaustible amount of complexities. To bring such a mission to the red planet from fiction to fact, NASA's Human Research Program has pinpointed 5 hazards that astronauts will encounter on their journeys. These include space radiation, isolation and confinement, distance from Earth, gravity or the lack thereof, and closed or hostile environments. Pulling the challenges of human spaceflight into categories allow for an organized effort to overcome the obstacles that lay before such a mission. However, these hazards do not stand alone. They can feed off one another and exacerbate effects on the human body, which are being studied using ground-based analogs, laboratories, and the International Space Station. These locations all serve as test beds to evaluate human performance as well as the effectiveness of strategies that could keep astronauts safe and healthy in space. Through meticulous research, NASA is gaining valuable insight into how the human body and mind might respond during extended forays into space. The resulting data, technology, and methods serve as a knowledge bank from which scientists can extrapolate multi-year interplanetary missions. 5 hazards of human spaceflight. Space radiation. Invisible to the human eye, space radiation is not only stealthy but considered one of the most hazardous aspects of spaceflight. What is space radiation? Outside Earth's protective magnetic field and atmosphere, the ionizing radiation in space will pose serious risk to astronauts as they travel to Mars. High-energy galactic cosmic rays, which are remnants from supernovas and solar storms like solar particle events and coronal mass ejections, can harm the body and spacecraft. When astronauts travel in space, they can't see or even feel radiation. However, NASA scientists are studying the effects radiation plays on the human body and developing ways to monitor and protect against this silent hazard. Space radiation element. The space radiation element, or SRE, seeks to characterize human health outcomes associated with space radiation exposure, helping NASA to build strategies that protect astronaut health and ensure safe human spaceflight. Space radiation is made up of protons and all the elements on the periodic table. It enters the human body at energies approaching the speed of light and can damage DNA. It is not a bird or a plane, but it might be a solar storm. We like to think of astronauts as our superheroes, but the reality is that astronauts are not built like Superman, who gains strength from the sun. In fact, much of the energy radiating from the sun is harmful to us mere mortals. Outside Earth's protective magnetic field and atmosphere, the ionizing radiation in space will pose serious risk to astronauts as they travel to Mars. High-energy galactic cosmic rays, or GCRs, which are remnants from supernovas, and solar storms like solar particle events, SPEs, and coronal mass ejections, CMEs, can cause harm to the body and spacecraft. These are all components of space weather. When astronauts travel in space, they can't see or even feel radiation. However, NASA scientists are studying the effects radiation plays on the human body and developing ways to monitor and protect against this silent hazard. Charged particles may be small, but they matter to astronauts. NASA scientists are investigating these particles to solve one of its biggest challenges for a human journey to Mars: space radiation and its effects on the human body. While people protect their eyes from the sun's radiation during a solar eclipse, NASA's space radiation experts are working to protect the whole human body from radiation in space. Space radiation is dangerous and one of the primary health risks for astronauts. In each life, a little rain must fall, but in space, one of the biggest risks to astronauts' health is radiation rain. NASA scientists are simulating space radiation on Earth following upgrades to the NASA Space Radiation Laboratory, NSRL, at the U.S. Department of Energy's Brookhaven National Laboratory. These upgrades help researchers on Earth learn about the effects of ionizing space radiation to help keep astronauts safe on a journey to Mars. While it is true that space radiation is one of the biggest challenges for a human journey to Mars, it is also true that NASA is developing technologies and countermeasures to ensure a safe and successful journey to the red planet. NASA's Human Research Program, or HRP, pursues the best method and technologies to support safe, productive human space travel. Through science conducted in laboratories, ground-based analogs, and the International Space Station, HRP scrutinizes how space flight affects human bodies and behaviors. Research drives HRP's quest to innovate ways that keep astronauts healthy and mission ready as space travel expands to the moon, Mars, and beyond. And next are some facts about the radiation exposure on a deep or outer space mission. According to the ESA, that's the European Space Agency, a recent data from ExoMars Trace Gas Orbiter showed that on a 6-month journey to the Red Planet, an astronaut could be exposed to at least 60% of the total radiation dose limit recommended for their entire career. Unlike Earth, Mars has no global magnetic field and a much thinner atmosphere, offering minimal protection against radiation. This means astronauts are constantly bombarded by radiation during the entire trip and the stay on the surface of Mars. The radiation dose astronauts receive during a Mars mission is several hundred times higher than they would experience on Earth over the same period. It is comparable to undergoing a CAT scan about 24 times. Prolonged exposure to high levels of radiation can increase the risk of cancer, damage to the central nervous system, and cause other health issues. Protecting astronauts from these risks is a critical aspect of a Mars mission planning. What are the countermeasures being taken or planned right now for defense or protection against cosmic radiation? Here are some countermeasures being developed and tested to protect astronauts from radiation on a Mars mission. Advanced shielding materials. Engineers are working on more efficient shielding materials to protect against high-energy particles. This includes using traditional spacecraft material with added mass or developing new materials that offer better protection. Water and waste shielding. Water already required for the crew can be strategically stored to create a radiation storm shelter. Additionally, processing astronauts' waste or shit into plastic-filled tiles can bolster radiation protection. Biomedical countermeasures. NASA is researching compounds like avasopacin manganese, CDDOME, metformin, and Y-tocotrienol to reduce the long-term health risks associated with space radiation. These compounds have shown promise in protecting cells and reducing the risk of cancer. Radiation monitoring. Continuous monitoring of radiation levels using instruments like the Radiation Assessment Detector, ARD, helps in understanding and mitigating radiation risks. Habitat design. Designing habitats with radiation protection in mind is crucial. This includes incorporating shielding into the structure and using materials that can absorb or deflect radiation. Spacecraft design. Incorporating radiation protection into every aspect of spacecraft design, from the materials used to the layout of the spacecraft, is also essential. Medical protocols. Developing medical protocols to manage and treat radiation exposure, including pharmaceuticals and other protective measures, is a key focus area. Why space radiation matters? Radiation is energy emitted in the form of rays, electromagnetic waves, and particles. In some cases, radiation can be seen as visible light or felt infrared radiation, while other forms like X-rays and gamma rays are not visible and can only be observed with special equipment. Although radiation can have negative effects both on biological and mechanical systems, it can also be carefully used to learn more about each of those systems. What is space radiation? Space radiation is different from the kinds of radiation we experience here on Earth. Space radiation is comprised of atoms in which electrons have been stripped away as the atom accelerated in interstellar space to speeds approaching the speed of light. Eventually, only the nucleus of the atom remains. Space radiation is made up of 3 kinds of radiation: particles trapped in the Earth's magnetic field, particles shot into space during solar flares, solar particle events, and galactic cosmic rays, which are high-energy protons and heavy ions from outside our solar system. All of these kinds of space radiation represent ionizing radiation. How much space radiation are astronauts exposed to? Beyond low Earth orbit, space radiation may place astronauts at significant risk for radiation sickness and increase lifetime risk of cancer, central nervous system effects, and degenerative diseases. Research studies of exposure in various doses and strengths of radiation provide strong evidence that cancer and degenerative diseases are to be expected from exposures to galactic cosmic rays, or GCRs, or solar particle events, SPEs. Millisievert (MSV) is a form of measurement used for radiation. Astronauts are exposed to ionizing radiation with effective doses in the range from 50 to 2000 MSVs. 1 MSV of ionizing radiation is equivalent to about 3 chest X-rays, So that's like if you were to have 150 to 6,000 chest x-rays. Where does radiation come from? Radiation can be created by humans, microwaves, cell phones, radios, light bulbs, diagnostic medical equipment applications such as x-rays, or naturally occurring, the sun, radioactive elements in the Earth's crust, radiation trapped in the Earth's magnetic field, stars, and other astrophysical objects like quasars or galactic centers. Earth's biggest source of radiation is the sun. The sun emits all wavelengths in the electromagnetic spectrum, EM. The majority is in the form of visible infrared and ultraviolet radiation, UV. Occasionally, giant explosions called solar flares occur on the surface of the sun and release massive amounts of energy out into space in the form of X-rays, gamma rays, and streams of protons and electrons. This is called a solar particle event, SPE. These solar flares can have serious consequences to astronauts and their equipment, even at locations that are far from the sun. Non-ionizing versus ionizing radiation. Radiation can be either non-ionizing, low energy, or ionizing, high energy. Ionizing radiation consists of particles that have enough energy to completely removing an electron from its orbit, thus creating a more positive charged atom. Less energetic, non-ionizing radiation does not have enough energy to remove electrons from the material it crosses. Examples of ionizing radiation include alpha particles, a helium atom nucleus moving at very high speeds, beta particles, a high-speed electron positron, gamma rays, X-rays, and galactic cosmic radiation, GCR, from space. Examples of non-ionizing radiation include radio frequencies, microwaves, infrared, invisible or visible light, and ultraviolet UV light. While many forms of non-ionizing and ionizing radiation have become essential to our everyday life, each kind of radiation can cause damage to living and non-living objects, and precautions are required to prevent unnecessary risks. Why is ionizing radiation more dangerous than non-ionizing radiation? While non-ionizing radiation is damaging, it can easily be shielded out of an environment, as is done for UV radiation. Ionizing radiation, however, is much more difficult to avoid. Ionizing radiation has the ability to move through substances and alter them as it passes through. When this happens, it ionizes the atoms, knocks electrons out of them in the surrounding material with which it interacts. Ionizing radiation is like an atomic scale cannonball that blasts through material, leaving significant damage behind. More damage can also be created by secondary particles that are propelled into motion by the primary radiation particle. The particles associated with ionizing radiation in space are categorized into three main groups relating to the source of the radiation: galactic cosmic rays, solar flare particles, and radiation belt particles, Van Allen belts, trapped in the space around the Earth. What is galactic cosmic radiation? Galactic cosmic radiation, or GCR, is a dominant source of radiation that must be dealt with aboard current spacecraft and future space missions within our solar system. GCRs come from outside the solar system, but primarily from within our Milky Way galaxy. GCR is composed of the nuclei of atoms that have their surrounding electrons stripped away and are traveling at nearly the speed of light. Another way to think of GCR would be to imagine the nucleus of an element in the periodic table from hydrogen to uranium. Now imagine that same nucleus moving at an incredibly high speed. The high-speed nucleus you are imagining is GCR. These particles were probably accelerated within the last few million years by magnetic fields of supernova remnants. In summary, GCR are heavy, high-energy ions of elements that have had all of their electrons stripped away as they journeyed through the galaxy at nearly the speed of light. They can cause atoms they pass through to ionize. They can pass practically unimpeded through a typical spacecraft or the skin of an astronaut. Are we protected from space radiation on Earth? Yes, but not entirely. Life on Earth is protected from the full impact of solar and cosmic radiation by the magnetic fields that surround the Earth by the Earth's atmosphere. The Earth has radiation belts caused by its magnetic field. The inner radiation belt, or Van Allen belt, consists of ionizing radiation in the form of very energetic protons, byproducts of collisions between GCR and atoms of Earth's atmosphere. The outer radiation belts contain protons and electrons. As we travel further from the Earth's protective shields, we are exposed to the full radiation spectrum and its damaging effects. In addition to our protective atmosphere, we are also lucky that Earth has a magnetic field. It shields us from the full effects of the solar wind and GCR. Without this protection, Earth's biosphere might not exist as it does today, or would at least be limited to the subsurface. What factors determine the amount of radiation astronauts receive? There are three main factors that determine the amount of radiation the astronauts receive or how radiation affects astronauts. They include altitude above Earth. At higher altitudes, the Earth's atmospheric protection is no longer present and the magnetic field is weaker, so there's less protection against ionizing particles, and spacecraft pass through the trapped radiation belts more often. Solar cycle. The Sun has an 11-year cycle, which culminates in a dramatic increase in the number and intensity of solar flares, especially during periods when there are numerous sunspots. Individuals' susceptibility. Researchers are still working to determine what makes one person more susceptible to the effects of space radiation than another person. This is an area of active investigation. Gravity fields. Floating weightlessly within a spacecraft can lead to dizziness, bone and muscle loss, vision issues, and more. Astronauts may also need time to adjust to new gravity fields after landing on the Moon or Mars before they conduct mission-critical tasks. Developing strategies that enable crew members to adapt quickly to different gravitational fields will be key to mission success. Astronauts will encounter 3 different gravity fields on a Mars mission. On the 6-month trek between the planets, crews will be weightless. While living and working on Mars, crews will be in approximately 1/3 of Earth's gravity. Finally, upon returning home, crews will have to readapt to Earth's gravity. Switching from one gravity field to another is trickier than it sounds. The transition affects spatial orientation, head-eye and hand-eye coordination, balance, and locomotion, with some crew members experiencing space motion sickness. Landing a spacecraft on Mars could be challenging as astronauts adjust to the gravity field of another celestial body. When shifting from weightlessness to gravity, astronauts may even experience lightheadedness and fainting. Without the continuous load of Earth's gravity, weight-bearing bones lose on average 1% to 1.5% of mineral density per month during spaceflight. Water and other fluids in the body shift upward to the head, which may put pressure on the eyes and cause vision problems. If preventive measures are not implemented, crews may experience an increased risk of developing kidney stones due to dehydration and increased excretion of calcium from their bones. Gravity fields. The problem. On the journey to Mars, astronauts will encounter 3 different gravity fields. Deep space. On the 6-month journey through deep space, the astronauts will experience weightlessness. On Mars, astronauts will need to live and work in 3/8 of Earth's gravity. Astronauts will have to adapt every time the gravity field changes. The human risk. Transitioning from one gravity field to another affects one's hand-eye coordination, balance, muscles, bones, locomotion, spatial orientation, and the heart. Without gravity working on your body, your bone density decreases by 1% per month. The key. The Human Research Program studies the impacts of space flights on and off the Earth. Specifically, researchers study astronauts' 1. Fine motor skills, 2. Fluid distribution, 3. Fitness and exercise protocols, 4. Vision, and 5. Response to pharmaceuticals. Astronauts who undertake the journey to Mars will need to be able to live, work, and explore in all 3 gravity fields. Not only to Mars, there and back again. Isolation and confinement. Behavioral responses occur among groups of people far from Earth who are isolated and confined in a small space over a long period of time. Crews will be carefully chosen, trained, and supported to ensure they can work effectively as a team for months or years in space. On Earth, we have the luxury of picking our cell phones and instantly being connected with nearly everything and everyone around us. On a trip to Mars, astronauts will be more isolated and confined than we can imagine. Sleep loss, circadian desynchronization, and work overload compound this issue and may lead to decreased performance, adverse health outcomes, and compromised mission objectives. To address this hazard, experts are developing methods for monitoring behavioral health and adapting, refining various tools and technologies for use within the spaceflight environment to detect and treat early risk factors. Research is also being conducted in workload and performance, light therapy for circadian alignment, phase shifting, and alertness. Behavioral issues among groups of people cramped in a small space over a long time, no matter how well they are trained, are inevitable. Astronauts selected for a stay aboard the space station are carefully chosen, trained, and supported. Crews for a Mars mission will undergo even more scrutiny and preparation, since they will travel farther and longer than any previous human, being more isolated and confined than we can imagine. The human risk. Some risks include decline in mood, cognition, morale, or interpersonal interaction. Development of a sleep disorder is possible. Factors include a small, noisy environment, the extra 38 minutes of daylight on Mars, or the stress of prolonged isolation and confinement. The trip to Mars will be demanding, alternating between heavy workloads and periods of boredom. The consistent lack of fresh food and variety may add to this sense of monotony and may also contribute to deficiency in nutrition, contributing further to psychological and physical imbalance. The more confined and isolated humans are, the more likely they are to develop behavioral or cognitive conditions. This development in individuals could contribute to team miscommunication. The key: NASA has been studying people in isolated and confined environments for years and has developed methods and technologies to counteract possible problems. Important factors for the crew's health include the amount of lighting, movement, and sleep a crew member obtains. NASA uses clever devices to monitor assets and improve these key human factors, but the crew would also be recommended to keep journals. Journals offer a safe place to vent frustration, but also as a tool that promotes mental and physical well-being. All of these methods and technologies will help us prepare for longer, farther exploration missions. Distance from Earth. Instructions, new supplies, medical care, and more become increasingly challenging to receive from Earth as astronauts venture deeper into space. Mars is, on average, 140 million miles from Earth. Rather than a 3-day lunar trip, astronauts bound for Mars would be leaving our planet for roughly 3 years. Given this distance, planning and self-sufficiency will be essential to successful missions to Mars, facing a communication delay of up to 20 minutes one way. The possibility of equipment failures or medical emergencies and a critical need to ration food and supplies, astronauts must be capable of confronting an array of situations with minimal support from teams on Earth. The Moon is 238,855 miles away from Earth. In contrast, Mars is on average 140 million miles from Earth. So far away, there will be no option for resupply. Planning and self-sufficiency will be essential to the success of a human mission to Mars. The human risk. With a communication delay of up to 20 minutes one way and the possibility of equipment failures or a medical emergency, astronauts must be capable of completing the mission on their own. Food will have to be pre-planned and medicine provided for a variety of possible situations. The key: NASA's Human Research Program is discovering what types of medical events happen in space over 6 months and what types of skills, procedures, equipment, and medication are needed. Astronauts perform ultrasound to monitor how the human body changes in space. The Human Research Program is studying and improving food, formulation, processing, packaging, and preservation systems to ensure the nutrients remain stable and the food remains suitable. Space-resilient medications and packaging that preserve the integrity of pharmaceuticals for long-duration missions are also being studied. Hostile, closed environments. Maintaining a safe ecosystem inside a vehicle presents unique challenges, from ensuring optimal temperatures, pressures, and lighting, to reducing noise, monitoring microbial communities, and tracking immune responses. The ecosystem inside a spacecraft plays a big role in the daily life of an astronaut in space. Microbes can change characteristics in space, and microorganisms that naturally live on the human body are transferred more easily from person to person in closed habitats, such as the space station. Stress hormone levels can elevate, and the immune system can alter, which could lead to increased susceptibility to allergies or other illnesses. More research is needed into whether these changes pose serious risks to astronauts beyond the effects of the environment on the immune system. Every inch and detail of living and working quarters must be carefully considered and designed. No one wants their house to be too hot, too cold, cramped, crowded, loud, or poorly lit, and no one would enjoy working and living in such a habitat in space either. The problem? The space environment is hostile and unsuitable for humans. Because of this, NASA knows the inside of a spacecraft plays a big role in an astronaut's life. Temperature, pressure, light, noise, air, and livable space all need to mimic Earth. If it takes roughly 6 months to get to Mars, it is essential. The living quarters of an astronaut are designed to encourage mental and physical healthfulness and productivity. The human risk: microbes can change characteristics in space, and microorganisms that naturally live in our body are transferred more easily from person to person in closed habitats. Your stress hormone levels are elevated and your immune system is altered, which could lead to increased susceptibility to allergies and other illnesses and disease. The key: technology makes it possible to monitor the air quality of the space station. Astronauts' urine and blood samples are analyzed to monitor health and can reveal important data such as stress levels. The spacecraft itself is also swabbed for analysis of the microbial population that inhabits the environment. Astronauts enjoy an LED environment that was designed and tested to simulate light similar to what you would experience on Earth. In space, an environment will have to close the loop, recycling all possible resources, including an astronaut's carbon dioxide and urine. Just like planet Earth, a closed environment needs to be more than a machine. It needs to be home. And finally, for my commentary to discuss these 5 hazards of human space flight, and I want to focus on the unsolved problems on these 5 hazards. Of course, these are ongoing problems and hazards that have been taken into consideration by NASA and other space agencies such as the European Space Agency, the
ESA,
Japanese Space Agency,
JAXA,
Indian and Chinese space agencies,
Indian Space Research Organization, and CNSA,
among others. And these hazards have not entirely been solved. They have not been eliminated, or adequate technologies for their prevention, their mitigation. Those have not been demonstrated or postulated in any credible manner. And when I say they have not, I mean they have not been publicly announced as being solved problems, and a demonstration or at least a postulation of the methods to solve those problems have not been completely and publicly announced to my knowledge. First, I want to tackle the problem of radiation when traveling to deep space. When I say deep space, I mean beyond the moon, such as missions to the moon itself, missions to Mars, missions to other planets, Venus, Mercury, other celestial bodies such as meteors, etc. So radiation, to tackle that, no ship has been constructed made with radiation shielding materials yet. To my knowledge, neither NASA, any other space agency, or any of the civilian space companies have demonstrated or unveiled any ships that are made of reliable and proven radiation shielding materials. Also, there have not been any credible demonstration of any anti-radiation drug that consistently and reliably works, nor a treatment for such problem of radiation. These, again, have not been demonstrated publicly, and to my knowledge, there have not been a safe drug that can prevent the effects of radiation on the human body, which again can include cancer. Also, there have not been any ethical anti-radiation genetic modification to my knowledge, nor genetic treatment. Of course, these are very controversial subjects, areas of science and medicine, flight medicine, that perhaps not too many doctors dare to engage in. And again, publicly, these have not been proven or demonstrated that any genetic modification is or will take place for the prevention of radiation sickness or radiation illnesses, such as cancer. To my knowledge, there is no mission design that has anti-radiation shielding, which is of proven technology or technology that is capable of working. Of course, radiation shielding could use 2 methods, what I call the passive method, which is just shielding using materials that shield from radiation. Human excrement is known to be one of them. Also, things or materials rich in hydrogen is known to be a radiation shield, as well as metals such as lead. But again, I have not seen any mission design or ship construction that includes these materials on their design. Of course, weight being a massive problem with current propulsion or rocket technology. A limiting factor is the weight of these materials, including water. Water, of course, has been known to be a great shield for radiation. However, for many forms of radiation, if not most, however, water is very heavy and difficult to contain. There is also an active form of radiation shielding through magnetic fields. Of course, the Earth and other heavenly bodies have magnetic shields around them, but these are enormous structures, enormous zones taking up kilometers in area, and this is very difficult to achieve in a relatively small structure such as a spaceship. It has not been postulated nor demonstrated in any current or upcoming technology. Gravity fields. The problems with gravity fields are many. No known effective artificial gravity technology has been demonstrated. That is huge. Of course, there are trials, there are studies, there are all kinds of developing and research technologies that are on the books and even on practice. However, none have been proven to work. By work, I mean they have not been proven to prevent the ill or debilitating effects of the lack of gravity or the effect of changing gravity fields. Of course, it could be less gravity, more gravity, etc., depending on the location of the individual. Exercise and drugs have been proven so far inefficient or insufficient for long duration of human spaceflight in 0G or near 0G or low gravity. Of course, they may help. Drugs that maybe slow down a bit the loss of muscle and bone density may help, however, not for very long duration flights, space flights of months to years. This remains a very thorny problem. Also, artificial centrifugal force gravity causes many problems, such as vertigo, disorientation, not to mention many technological problems that have not been solved, including ship design, the lighting or natural sun lighting, etc. There are postulated designs from various companies and agencies such as NASA. I believe there's also a design proposal from the company from Robert Zubrin, the leader of the Mars Project, which is a non-profit organization, private organization. However, these problems with gravity, the lack thereof, or too much gravity or little gravity have not been solved completely or to the point to where a very long-lasting space mission is possible without the debilitating effects of it. Of course, some of the artificial gravity technologies that exist or that have been postulated and sometimes demonstrated include rotating structures. Of course, when you rotate something from a center, it creates centrifugal force, and the idea is that humans could inhabit such structure like a ring type structure,
A torus.
a donut shaped type structure which is rotated. These structures have the problem that they need to be extremely large to create any kind of significant centrifugal force. And of course, that introduces the problem of the vertigo disorientation that comes with centrifugal force. The body does detect that there is a movement. Of course, spacecraft like that would have to have no windows, no natural lighting from solar light or any other kind of light source from natural sources, space, and that brings other problems to the situation. So these have not been solved. The next hazard I want to tackle and tell you about it, how it has not been solved and it remains a problem for space flight, is the problem of isolation and confinement. The problem with isolation and confinement is the nature of space itself. Space is enormous, and short of huge space-based habitats, isolation is inevitable. Trips and travel times will be very, very long, very lengthy, and we'll have to traverse immense areas of space. Therefore, by its very nature, space is very solitary, quiet, and very empty. And by its very nature of space flight, the isolation of these spaceships will be, I believe, to be inevitable. Also, spaceships will remain small for the foreseeable future. Very large and kilometer scale
Colossal
structures are not in any kind of credible or postulated plans with any of the space agencies, let alone any space company. So ship design remains relatively small, therefore they are confined spaces. They are small and confined spaces for the crew. Also, our current propulsion systems limit the amount of space that spacecraft have available for the crew, because much of the space, majority of it, is taken up by fuel and the propulsion systems that use that fuel. Also, human nature is still primitive and emotional and often violent, as we often witness in our everyday happenings, the news, even in our own personal lives. We know and experience these problems. They are problems here on Earth, let alone in space. I say human nature is very primitive because we often revert to very emotional and violent behaviors that we know better not to engage in, not to follow, or not to act upon, yet we very, very frequently engage in those. Some of those include greed, hierarchy, and old and I would say obsolete power structures that surely will affect space-based or space flight and their missions. Also, sexual tensions are likely to lead to competition among people, among humans, rivalry. With that could come even some hostility and even violence. Also, political, social, racial, and economic differences that crews will surely have will play factors for tensions and hostilities and even conflict in space. Distance from Earth. Short of warp drive and the use of wormholes, which are still very speculative and theoretical conjectures in books, the distance from Earth is an inevitability. It must and will happen. It must and will exist. Distances beyond the moon are vast to the nearest celestial body. Distance to Mars in miles is about 140 million miles, which is mind-baffling, let alone other more distant celestial bodies such as Jupiter, Saturn, Uranus, etc. Also, current propulsion systems limit speeds of travel. We depend on the old rocket, which is a very old technology, nearing now 100 years old, and that is the modern version of it. The very basic version of it goes back even farther. So relativistic, or speeds nearing the speed of light, are only hypothetical conjectures again, and will remain so for the foreseeable future. Also, generation ships raise ethical and biological problems for humans. For example, the crew that will be volunteering for such generation ships will be not only volunteering themselves, but be volunteering their offspring, their future generations that they will have to create in order for the multi-generation mission to be accomplished, to be completed. So that's an ethical issue there, or problem, among many others. Also, biological problems that are either unknown or not solved so far, such as how will humans be able to reproduce in space, not only have sexual intercourse, but also give birth. How will artificial or even little or no gravity affect the body's ability to reproduce? And not only that, but how will gravity fields or altered gravity fields affect human development, growth? This has not been studied at all, of course, because this has not occurred. Of course, there are speculations and educated guesses of what may happen, but this has not occurred with humans. Of course, I believe there has been animal tests. I'm not sure to what degree mammals have been or have given birth in space. I will update this chat, the show notes, the comment section, or in any other way, look for that. Finally, the last hazard to be discussed here is closed and hostile environments. Again, short of generational arcs, ships will remain closed environments for the foreseeable future. Also, space is naturally hostile. It's a naturally hostile environment for humans and human biology. Of course, humans are acutely and exclusively evolved for Earth conditions. So low or no solar light affects human mood and behavior and even biology. Extreme temperatures, cold, hot, extreme dryness also is harmful. High radiation and toxic atmospheres do nothing but add to the list of technical and biological unsolved problems in human spaceflight. So far, wherever humans go away from Earth, they need to duplicate Earth environments. This means closed-off structures with artificial atmospheres and systems that can provide the air, water, gravity, and other resources that Earth naturally provides. And the problem with this is that this has never been tested outside of low Earth orbit or on the surface of another celestial body. Yes, there have been very limited and short duration tests of artificial systems on the moon. However, these have been only for very short durations, few hours, and they have not been permanently or semi-permanently attached to the moon. The moon has not been settled with any kind of semi-permanent or permanent structure. So we have no practical experience directly on another celestial body. Yes, there have been runs and tests and experimentation done here on Earth, in very extreme environments on Earth. But the most extreme environment on Earth is friendly when compared to the most friendly of environments in other worlds such as Mars, Venus, Mercury, or any other of the solar system planets, let alone celestial bodies outside of the solar system. So these problems, these 5 hazards, are or make the list of the 5 hazards because they remain problems, the issues that remain unsolved by not only NASA but every other space agency, let alone any other civilian private corporation or space corporation. So we as humans need to, 1, recognize this. 2, we need to work on these problems diligently, and I believe more focused and diligently than we have. And if you want to explore space, let alone colonize it or colonize any other planet or celestial body, then we need to ramp up these tests, these advances, these solutions. For that, we need to heavily invest more in space agencies and their projects. We need to more seriously put goals on the table and go for them. These have been very vaguely announced over the years. Every U.S. presidential administration seems to, by routine, announce some sort of plans for the future for NASA and space exploration. However, these are often abandoned, changed, underfunded, and canceled altogether. And that needs to change, I believe. We need to focus, laser focus on a goal and relentlessly and consistently support that goal, fund that goal, and go for that goal. Perhaps this has happened because we really don't have any or much of a reason to venture into other worlds, into other celestial bodies, planets, etc. We have plenty of problems here on Earth still to solve, to sort out. We are not still able to sort out problems without war, violence, killing, without militaries being involved, without weapons of mass destruction and other being involved. So exploring other worlds, uniting, cooperating, teaming up to travel to space seems to be much up the scale, much up the ladder, a lot higher in the ladder than we currently are. Again, we are still reverting to very violent and animalistic behavior with each other, with other nations, with other cultures, with other religions, with other communities. So we cannot hope to unite, put our differences aside, leave our differences behind, and cooperate as a world, because I believe this very much. It will take nothing but the cooperation of the entire Earth, the collection of societies, civilizations, countries, nations of Earth to go as near as the moon or Mars and remain there for any kind of lengthy period. It will take the cooperation of many, many nations, perhaps all the nations that can help, that can contribute. It appears that we're not there yet. We're not cooperating with nations like China for whatever reason, for tribal reasons, for cultural differences that we can't seem to put aside. And we remain to get to that stage, get to that point first before we even think about Ark-like generational ships to other solar systems, to other stars, or even to nearby celestial bodies like other planets and moons.
Thank you for listening to this podcast or watching this video. Please subscribe, like, and share so you can support this work and so I can reach more people like you. If you'd like to support this content further, please click on the links provided here. Thank you again. Have a great day.